Hello and welcome to this T-Analyst manual video focusing on camera calibration. Calibrations are made in a standalone software named T-Calibration. The software can be found in the download folder together with T-Analyst. And this software relies on connecting points in the camera view to the real-world points. And the easiest and fastest way to calibrate the camera view is to use an aerial image with a known scale. Google Maps or Google Earth is excellent at this in most cases. So this is what it looks like when you first start up. This is T-Calibration. And what you want to do first is to create a new project. This is done by pressing either this button or simply by pressing Project and New. So that is what we're going to do. For the purpose of this video, I already have a new project created, so I'm going to open that one up. Then we do it like this. We open project, and the project I have is manual project, and it's always this calibration file type thing. So I open this one up, and this is what it looks like. You got your system in the middle, and right now we don't have a map image or a camera image, but we're getting to it. So first thing first, we need to import a map image. Simply double click map, and then choose where you have the image you want to import. I have mine right here, map.png. Has to be a PNG. Okay, so open. Simple as that. Next step, we need a camera image. Now you simply press this red plus sign and choose the camera image. Camera -1. Also PNG. There we go. Now I have both the map image and the camera image. Next thing we want to do is we want to define the scale. So the camera actually, or so the system actually knows how far apart our points are going to be. We simply press this button over here. That gives us the opportunity to choose a scale. And this is where the scale comes in. So you have to actually have a defined scale in the image. I'm going to do something like this. And then I'm going to take the far corner on the other side and define the parameters. The first one is x.00, y.000. This one is 5 and 0. Simple as that. What we now defined is that from this edge on the left side to the edge on the right side, there is 5 meters. So 0 movement in the y direction, 5 meters movement in the x direction. Simply press OK, and the scale is defined, and our system sheet is down here. But we can quickly move that, press there and there. Worth noting is that when you import this into T-Analyst later, the car is always going to drive towards the X. So place it the way you want to have it. I'm going to rotate mine like so. Okay, and that's that. Next thing is starting to import a lot of points. And the important thing here is that you actually choose places that are visible both in the camera view and in the map view. So if we start by adding a point by pressing this red plus sign and then this one. Let's start by putting them on the zebra here. This is very easily definable. As you can see, I can find the same thing right here. And the more time you put down in this, the better it will be. Adding more points simply by pressing the plus sign again, you get a new one. You place that one. the idea is to get a even grid across the entire view. So I'm going to cut now to a more finished version of this manual project, so you can see how I've done it. Okay. All right, so this is how the project looks now. I've added in a lot more points, changed things up a little bit, but more or less it's the same image, still the same camera image. As you can see, the zebra lines are really easy to find points in, and then you have to get a bit creative. So these are some manholes, these are zebra lines over here as well, but that over there, I don't know what it is, but it was visible in both views. So that worked out fine, and now it's a more evenly distributed grid. What you want to do now is that you want to go to the map image and choose world model and use existing points, because now we're going to get ready to calibrate this. So this will select all the points, they will turn green. You will go back to camera 1 and click calibration, and calibrate and flat surface. And this will give you the, will tell you the average error, how much the offsets are. And the average here is about 10 centimeters. So I would say that that's fairly okay, considering that is 1 or 3 pixels. Okay. This will then give you, let's see where that happened, calibration project. This will also create a folder within the calibration folder, which is where you will have the 2 most important files for further analysis with T-Analyst, and that is the TA cal file and the TA map file. But you'll also get some statistics like the camera accuracy. I'll try to bring it up here on the screen. There we go. Camera accuracy. This will tell you how accurate the camera calibration have been. And you can see that over the first 2 zebras we are very, very accurate. But the further away we go and the more distant spaces it is in our grid, the more the calibration will lack. But this is overall a quite good calibration. As you can see here in the red area, there's an offset of approximately 0.0 meters. But we didn't have any points over there at all, so that's quite understandable. We'll also get the grid files, so you can see how it looks in 3D. And the height, which we unfortunately are not using right now, because then you would have to go out and measure the points yourself to get the actual set coordinates. But all in all, that's it. These are the 2 files that you will need to keep analyzing with T-Analyst. But all in all, thank you for listening, and good luck with the calibrations.